Hello everyone. I'm Masumura from Machine Vision Lighting Incorporated, Japan. Starting today, I'd like to give a series of talks on the essential lighting and imaging technologies for machine vision via method lighting. We're learning the basics of lighting and imaging systems from the essence of light. The most basic of lighting and imaging systems, the visa method is actually the origin for all lighting methods, lighting technologies, and of course, imaging technologies. Simply put, which direction the light is irradiated from and which direction it is viewed from can be uniformly controlled. This is the visa method. Visa is variable irradiation solid angle. On top of that, visa lighting can quantitatively control the shape of the light. In terms of conventional lighting, at what angle, at what distance, and from which direction it is viewed. I'm going to give an overview of this in two parts. This is the first part. First, machine vision lighting. Obviously, it has become quite popular now, but back then, no matter where you searched on the web, you wouldn't find this term. Lighting technology for machine vision is a new technology that has been developed over the last quarter century. And by 2011, through JIA, Japan Industrial Imaging Association, this had become a global standard, recognized worldwide as a new lighting standard for machine vision and image processing systems. What I am going to talk about from now on is the visa variable irradiation solid angle method lighting, and there will be a total of 7 episodes. In the first episode, I'm a little greedy, but I'll talk about visual function, seeing light, and then about light and objects and observation of object light. In the second episode, the essence and approach of the visa method. In the third episode, the basics of the visa method. In the fourth episode, the effects and the application of the visa method. In the fifth episode, a new approach to the visa method. In the sixth episode, future developments of the visa method. In the seventh and final episode, the new horizon that the visa method will open up. So this time, I'm going to start off by giving an overview of all 7 episodes. But since the first episode is the heaviest, I'll only be talking about the overview up to the first episode this time. First, this is the first episode about visual function. Visual function is, well, the visual function of machine, but you need to be aware that the visual function of a human being and the visual function of a machine are not the same. Well, that's just how it is. For example, take Pinocchio. Pinocchio wants to become a human, and he begs the angel to turn him into a human. But while he is still a marionette, he can already see the apple. But can he really see it? It's not an exaggeration to say that this marionette is a mechanical doll. No matter how sophisticated a computer is, it's still a mechanical doll. So, can this robot recognize an apple? The answer is actually no. The reason it can't is that Pinocchio wanted to become a human because he wanted a heart. Robots don't have hearts. This means that because visual function is actually a function of the psychological mind, robots can't use their visual functions in the same way as humans. Well, in that context, the next step is seeing light. And with human eyes, of course, we see light. In the case of a robot, it's a lens, a light sensor, and a camera, but before it gets into the lens and camera, it's a physical quantity. The changes in the electromagnetic waves emitted from the apple are imaged on the retina by the eye's imaging optical system, and the light intensity information is converted by the photoreceptor cells into electrical signals. How bright is it? What kind of energy is it? And in what direction? Since light is actually a wave, there are four factors: wavelength, amplitude, vibration direction, and light propagation direction. And when it hits the retina, it reacts as a particle. In other words, it can only react as a photon. So what is happening on the retina here? We count this light not as a wave, but as photons. So an image information is actually all about light and dark information. You might say, well, there is color. But color comes from the fact that on the human retina, there are three cells called LMS cells, which have different sensitivity of wavelength band. And the brightness of each of these cells, these three cells, is assigned to RGB as a psychological quantity in the human mind. Incidentally, color is the ultimate psychological quantity. So there is no physical quantity called color. It's called spectral distribution, if I had to say. Next. The information converted into electrical signals by the photoreceptor cells is transmitted by the optical nerve to the cerebrum, which perceives this as signal information, and the image information perceived by the brain is transmitted to the world of the mind, and the mind recognizes it as an apple. So if the human brain could be completely realized by a computer, then according to the view of brain scientists, then it would be the case that robots would also be able to exercise their visual functions. But after all, they say that the mind is also created in the brain. In fact, however, it is clearly not the case. No matter how much we use neural computers, we can create something close to the human brain or even surpass it, such as a quantum computer. But then, can a robot use its visual function and think actively on its own? The answer is no. So what should we do? In human vision, image information converted by the eyeball is evaluated in the mental world as psychological quantities. But in machine vision, it is necessary to analyze the changes in the physical quantities of light as electromagnetic waves and derive conclusions. To achieve this, lighting must not simply make an object brighter, but must provide a highly controlled change in the object light retained from the object and optimize changes in physical quantities. Since the vision of a machine or robot can only deal with this physical quantity, When the apple is photographed, it is necessary to capture an image that is sufficient for the system to recognize it as an apple. Moreover, at the time the image is captured, it is already decided that the computer will recognize it as an apple. In other words, the type of light to be irradiated determines the object light, which is determined by the optical properties of the object. And this image will result, so you could say that at the lighting stage, most of the machine's visual function is already decided. Therefore, if the lighting stage does not provide a quantitative image before the image is obtained, it will be failure. Therefore, it is necessary to capture 3D information, which is usually called quantitative image data, but this is the opposite. If you obtain quantitative image data, you can also reconstruct 3D information from it. And what this means is that you need to quantitatively supplement the direction of light propagation. If you can't do this, you can't obtain quantitative image data, and then you can automatically convert 3D information from image data. This means that in order to give a machine a visual function, it is necessary to obtain quantitative image data. Next, regarding lighted objects. If it were pitch black, you wouldn't be able to see anything. When light is irradiated from a light source, the object light becomes bright. In other words, it is emitting object light. But this object light is not actually the light that is irradiated and returned. The irradiated light is first absorbed by the apple. After that, when this light is emitted from the apple as object light, the type of object light it becomes is determined by the optical properties of the apple. Humans are capable of flexible vision based on psychological quantities, but machines can only recognize an apple as an apple by analyzing the object light as a physical quantity. This means that in this state, it is extremely important to irradiate the object with light as accurately as possible. As a result, quantitative image information must be obtained, and visual recognition can be performed by machines. Well, that's all for today. Thank you very much for listening to the end. Please look forward to the second half of the overview. See you next. Bye.